Last time we got the car working with the 100-watt motor, but the gearing was quite high. The car would struggle to get off the line and then reach quite a high top speed. And because of that, the motor was overheating. But probably the biggest problem I found with the way I've made the car the first time around was that the sprocket carrier and the brake disc carrier were wonky. And so they weren't running quite true. So the chain would fall from time to time, and the brake disc was rubbing on the brake pads, slowing the car down. And that's not ideal when your car is already underpowered because of the wrong gearing on it. The way to fix this would be to get the lathe and make the sprocket carrier out of a block of aluminium, but that's quite expensive, and so I took the cheapest option and bought a second-hand 3D printer off of Facebook Marketplace. So do you think we can take the motor off and then take these off again? And then we'll use our new tool, the 3D printer, and we're gonna make better holders for the sprocket and for the brake disc, and then it's gonna be much better that way. I spent the next few days printing random stuff off of Thingiverse just to keep the kids happy and show them how the new tool works, and it also gave me the opportunity to tinker with the printer and understand what are its strengths and limitations. It's been about 12 years since I last used a 3D modeling software, and this is my first attempt at designing the sprocket carrier. And this was pretty straightforward, just a couple of concentric circles. I'm now using Cura to slice the model, and I'm using a 50% infill. This is just the first attempt. I think I might have to adjust some of the holes here because there might be a bit of expansion of the plastic material. So I'm going to give it a go with the 50% infill and 8mm wall thickness, and then we'll see how it goes. I proceeded to print this out of PLA, and I know everyone's gonna say PLA is not the best material for this application, it's a structural component, la-di-da, but for me this was the best material because I had it, and I didn't have to order a new material, I didn't have to wait for it, and more importantly, I didn't have to pay for it. Now this hasn't turned out very great because I changed the settings to make it coarse because I didn't really care about the finish of it, but I was a little bit worried that it might not fit, but it fits just right. You can see how it's not quite nice and round, but it fits in here all right, and the bolt holes align. I just need to check and make sure it goes over the axle. So the sprocket holder is not done. I just need to make the same for the brake disc. Now I've done my two prints. This is the first print. This was done for the sprocket and this was done for the brake disc. And you can clearly see a difference in the accuracy and quality of the print. And the reason for the poor print on this one is because of the settings I used in CATIA when saving it as an STL file. So when I was designing this one, I figured out why this one came up so badly. And so you can check out online how to save STL files to get better accuracy, but that was the issue with the first print I made. So the first prototype of the sprocket carrier, the one that printed poorly, has broken already. I had basically this was together and there was a cotter pin going through the axle and it just ripped it clean off. And this was actually fully like solid printed. The infill on this portion was nearly 100%, and it still broke off, maybe because of the thin walls that I used. So I made a second version with much thicker walls, and so hopefully this time around it will work. Okay, go.
the donut.